So this is the fourth week of our class, and today we are working on probability. And in probability, we are solving some of the important problems, which will be very helpful in solving your regular problems in Math 135. So we will begin with the first example here. Let's find out what is asked in this problem. Find the sample space for 2 coin tosses. So here you can see the 2 coins are tossed and we need to find the sample space. You know that we can find the sample space using the tree diagram or by making the table or any way you want. What I'm going to do is I'm going to make a table here. When you toss the first coin, you can follow along with me. When you toss the first coin, you may get a head or a tail on the first, or on the second coin, you may get a head or the tail. So if you want to write all possible outcomes, then the possible outcomes will be the first one is head and head. We are asked to write as ordered pair. So we write that as H comma H, head and head. If you get head on the first and tail on the second, that will be head tail, head comma tail. If you get tail on the first and head on the second, that will be tail head. And then this one is tail and tail, which is written as TT. So I represent the all possible outcomes here in the form of a table. And when you write that as a sample space or a set, we write S equal to, your first outcome is HH, second is HT, third is TH, and the fourth one is TT. That is your sample space. And you can see that there are 4 possibilities. 1, 2, 3, 4. The set of all outcomes that you list, that is called the sample space. Do you have any question in first example on how to find the sample space when 2 coins are tossed?
No.
Okay, great. Here is the second problem. So in this one, we are talking about the sample space for 3 coin tosses. So in the first example, I draw the table. In this one, I'm going to draw the tree diagram so you'll have the idea of each of them. So here we have the 3 coin toss. In the first toss, when you toss the first coin, you may get a head or a tail. That is the first. When you toss the second coin, say for example, on the first coin you got a head. Now in the second coin, you may get a head or a tail. Or the other one is, on the first toss, you got a tail. So in the second, after this, you may get a head or a tail. So head or a tail. Okay, so this is the first toss. This is the second. We need 3. Now, if you look at this one, first you got a head. Second, you got a head. So third, you may get a head or a tail. So after this, you may get a head or a tail. This one, first you got a head. Second, you got a tail. Now third, you may get head or a tail after this. So you may get a head or a tail. This one, first you got a tail, then you got a head. After this, you may get a head or a tail. Here, first tail, second tail, then after that, when you toss the third one, you may get a head or a tail. So if you look at the outcome, the first outcome is, see, the first one is head, head, and head. So this is head, head, and head. Second is head, head, tail. Second is head, head, tail. The third is head, tail, head. So we write that, head, tail, head. Next we have head, tail, tail. So head, tail, tail. Then we have tail, head, head. So this is tail, then head, head. This one, first tail, then head, then tail. So head, tail, no, tail, head, tail, tail, head, tail. This one here, 2 tails and then head. 2 tails and then head. And the last one, you have all tails. All tails. So I wrote the outcomes using the tree diagram, but we are asked to list, that is, we have to separate by comma and write as ordered pairs. So if I write that sample space as, the first outcome is head, head, head. So head, head, head. When you write as ordered pair, you have to put the comma like that. Second, you have head, head, tail. Third is head, tail, head. Fourth is head, tail, tail. Fifth one is tail, head, head. Then you have tail, head, tail. Then you have tail, tail, head, and tail, tail. Hold on. That is tail, tail, tail. So that is the outcome. So when you toss 3 coins, in each coin you have 2 possibilities. So when you do it 3 times, 2 times 2 times 2, that'll be equal to 8. So you can count here 1, 2, 3, 4, 5, 6, 7, 8 outcomes. That is your sample space. Okay, any question on how to find the sample space by tossing the coins? You can
No.
unmute yourself. Okay, good. Okay, let's move on to next example now. Let's find out what is there. Here is the other one that is about the spinner. And here also we are learning how to find the sample space. You can see here our spinner consists of 4 options: 0, 1, 2, 3. 0, 1, 2, or 3. That's what you will get by spinning that spinner. The spinner is spun twice. We have to find the sample space by listing all possible pair. In other words, list the outcome of the ordered pair for spinning 1 and 2. So let's try the table this time again. When you spin the first time, the possibilities are 0, 1, 2, and 3. So you may get 0 or 1 or 2 or 3. These are the possibilities when you spin the first time. When you spin it for the second time, you'll get 0, 1, 2, or 3. So again, 0, 1, 2, or 3. So we'll make this table. Let's draw that table first, and we'll list the all possible outcomes. Now, the possible outcomes are, the first one can be 0 and 0. That is 0 on the first spin and 0 on the second. Then you may get 0, 1. That is 0 on the first and 1 on the second. Then 0, 2, 0 on the first and 2 on the second. Then 0, 3, meaning of that is 0 on the first and 3 on the second. Or this one here, 0 on the first, 1 on the second, 0 on the first. No, hold on. I make a little mistake. Did you notice that? No? See here?
1 first.
Yes, 1 on the first and 0 on the second. That's right. 1 on the first and 0 on the second. Then 1 on the first, 1 on the second. 1 on the first, 2 on the second, right? And then 1 on the first, 3 on the second. 1, 3. Like that. Okay, let's complete that. I know you have the idea now. I'm just going to write it down. Please copy that or complete that in your note catcher also. 2, 0, 2, 1, 2, 2, 2, 3. Then the fourth line is 3, 1, 3, 2, 3, 3.
3, 0.
Yeah, look at that. My brain is not working good today. 3, 0. You are right. 3, 0. Then 3, 1, 3, 2, 3, 3. Okay, so yeah, so we have all possible outcomes here. All we have to do is we have to list that, okay, by listing. So we write as equal to, and we list all of them. Please list them. 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3. There are so many. Then 2, 0, 2, 1, 2, 2, 2, 3. Then I have with 3. So 3, 0, 3, 1, 3, 2, 3, 3. Okay, that is the sample space. So you can see here on the first spin, you'll get 0, 1, 2, or 3. So 4 possibilities. And this side also you have in the second spin 0, 1, 2, or 3, 4 possibilities. So 4 times 4, 16. So when you count these outcomes here, the total number of outcome is equal to 16 because it is 4 times 4. Okay, question on how to write the sample space in this example.
No.
No.
Very good. Let's go to next example then. So I think this is the last example on writing the sample space. We are pretty much reviewing everything that we have done in our regular Math 135 class, taking some easy examples here. Okay. In this example, you may see this little differently in your note catcher, but you have exactly same questions there. Determine whether these sets are mutually exclusive. When we say mutually exclusive, meaning of that is we are looking at the disjoint sets or there is nothing common. Okay. Write yes if they are mutually exclusive. So what I'm saying is if you have the event A like this and event B like this, and they are not joined, you can see here, they do not share anything in common. This is mutually exclusive. But if you have A and B and there is something common like this, okay, in my second figure here, they share something common. That means this is not mutually exclusive. Not mutually exclusive. Not mutually exclusive. So what we have to do is we have to check whether they are disjoint or not. Mutually exclusive means they are disjoint or not. So let's read each of these. The first one is roll a 6-sided die. That is the experiment. And the outcome is, or the event is, A is the set of numbers rolled that are greater than 4. When you roll a number, when you roll a die, okay, what are the numbers greater than 4? What are those numbers? 5 and 6, right? Numbers greater than 4.
Yes.
And the second is, what do we have here? The second part is B is the set of numbers rolled that are odd numbers. What are the odd numbers? They are 1, 3, 5. Now, so these are the two events. The first one is 5, 6, second is 1, 3, 5. Do you have anything in common? Look at those two. I want you to unmute yourself.
Yes, 5.
5 is a common. So are they mutually exclusive?
No.
No. So the
Okay.
answer is no. We just have to write yes or no. So no, because they are not mutually exclusive. Okay, that is what it is. That's the first one. Let's go to the second. Second is pick a college student at random. That is your experiment. And in the first one, A is the set of students who work full-time. A is the set of students who work full-time. They work full-time, okay? And B is the set of students who smoke. B is the set of students who smoke. Do you think that there will be a commonality between these two? The set of students who smoke can also be full-timer, right?
Yes.
So there is a common between those two. So we are looking at this one. So for the first part, for mutually exclusive, is it yes or no? Do they share something common?
Yes.
Yes, that means they are not mutually exclusive. So the answer for this is no, because they are not mutually exclusive. Okay. Let's look at C. In C, your experiment is flipping a coin. And by flipping a coin, what you're looking at is set C is the outcome of getting tail. So when you're looking at C, that is only the outcome of getting tail. And D is the outcome of getting head. Do you think that there is a common between these two? The first one is only head. The second one is only The first one is tail, the second one is head. Is there a common between these two?
No.
No.
No, that means they are mutually exclusive. Yes, they are mutually exclusive. So the answer is yes. And then the last one. Again, pick a college student at random. A is the set of students who work part-time. Okay, A, these are part-time students. And B is the set of students who drink coffee. Who drink coffee. Do you think that the student who work part-time drink coffee? Is it possible?
Yes.
Yes, that means there is a common between these two, right? There is common between these two. So this is the case. We are looking for this one. This is not the case. So the answer is no. The answer is no. So in this example, what we are able to do is we were able to identify whether the events are mutually exclusive or not. Because in your Math 135 class, once you know the events are mutually exclusive or not, you have a specific formula to calculate the probability. Here we are not calculating the probability, we are just classifying these events as mutually exclusive or not. Any question that you have on this example?
No.
Okay, great. Next example then. Answer each of the following questions. So here we have 4 questions. And what we have to do is, let's see the first one. Let A represents the event with probability 35%. When you say probability of 35%, meaning of that is probability is 0.35, right? Because we write the probability as a decimal, a number between 0 and 1. So that is 0.35. We have to find the probability that the event A will not occur. So that is the complementary event. If you remember the formula, probability of A, probability of any event, let me write probability of E, probability of any event E plus probability of complement of E or not E is equal to 1. So meaning of that is, if you want to find the probability of not E, that is equal to 1 minus probability of E. That was the formula. So here we have to find the probability that event A will not occur. So we want probability of not A. And probability of not A is 1 minus the probability of A. So the probability that event A will occur is 0.35. So 1 minus 0.35. Subtract that in calculator and tell me what you'll get. 1 minus 0.35. What do you get? Are you working on your calculator? 1 minus
0.5.
0.65.
Just 6.5.
Okay, 0.65. That's right. So whenever you are calculating the probability of not A, that is 1 minus the probability of the event. So to look at B, let B represent an event with probability 98.9%. Probability of 98.9%, that is 0.989. That is the probability. We have to find the probability that B will not occur. Probability of not B is equal to 1 minus the probability of B. Probability of B is 0.989. Help me again, please subtract that. 1 minus 0.989. What is that equal to? Use your calculator and give me the result. What did you get? Please unmute yourself when you're talking.
0.011.
0.011. Very good. Yes. If you write, you can write 4 decimals. So in that case, you can put 0 at the end. Definitely. Yes. Great. That's your B. Now look at C. Let C represent an event with probability 0.726. It's already given. Probability is 0.726. That's for probability of C. We have to find the probability of not C. That is, probability of not C or C prime is equal to 1 minus 0.726. Again, please subtract that in your calculator and give me the result.
0.274.
0.274. Thank you. Okay. So in all this example, we are finding the complementary probability. If you look at the D represents an event with the probability that one. See, probability 0.12345 zeros and 1, 2. We have to find the probability that D will not occur. So we have to subtract this. Probability of not D is equal to 1 minus 0.12345 zeros and then 1, 2. You can subtract this in your calculator by removing all those decimals. So you'll get 0.123459, then 88. Okay. If your calculator is not fixed, if you're including all the decimals, then you should get 0.123459 and then 88. So the goal here is to work on the complementary probability. When you add the probability of event plus probability of not, or the complement of the event, that's equal to 1. Or in other words, probability of happening an event plus probability of not happening an event is equal to 1. That means probability of not E is equal to 1 minus probability of the event. So we use that formula and calculated these probabilities. Any question in this example?
No.
Great. Okay, we'll go to next example then. Here we go. So these are also based on the complementary probability. Let's see. Answer each of the following questions. S equal to, so S is the sample space or the total possible outcomes. And here we have A, B, C, D, E, F, G, H. That is 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. And the event R is E, F, G, which is 3 of them. We have to find each of the outcome in S are equally likely. We have to find the probability of R. So if you want to find the probability of R equal to how many elements are there in R, you can count. There are 3. Okay, 3 out of 8. So that is 3 out of 8. You can leave that as a fraction like that, or when you change it to decimal, it should be 0.375. That is probability of R. Also, we are asked to find the probability of not R. Now, next is we have to find probability of not R. What we know from the previous slide is probability of R and probability of not R is equal to 1. So that means probability of not R is 1 minus the probability of R. Probability of R is 3 over 8. So 1 minus 3 over 8 is 5 over 8. Or when you change this to decimal, it should be 0.625. Okay, so that is the probability of R and probability of not R. Still, we are working on that complementary probability where we say probability of any event E plus probability of complement of the event E is equal to 1, which implies probability of complement of the event is equal to 1 minus probability of the event. We are still using that formula. Any question on part A? Waiting
No.
for your response. Okay. Let's go to the second part then. S represents the sample space for all days in non-leap year. So when we say all days in non-leap year, how many days are there in all? In non-leap year, how many days are there in 1 year?
365.
365, very good. So your sample space S contains 365 elements. Now the event is, let A represent the set of all days in February. So in non-leap year, how many days are there in February?
28.
28. That means what is the probability of selecting a day in February? If you want to find event A is the number of days in February. So probability that a randomly selected day falls in the month of February is 28 out of 365, right? That is the probability, 28 out of 365. Now, the question is find the probability of event A. We got that. Probability of event A is 28 over 365. Or if you change this to decimal, it should be, you can divide this in your calculator, it should be 0.0767. Okay, probability that the randomly selected day is in the month of February is 0.0767. Also, we are asked to find that the randomly selected day is not in the month of February. That is, A will not occur. So probability that it's not A is equal to 1 minus the probability of A. Probability of A is 28 over 365. 28 over 365. And if you subtract that, 365 minus 28 days will be 337 days out of 365. And when you change this to decimal, you should get 0.9233. Questions here, if any? I am waiting for your response.
No.
No question? Okay, great. Next example. In these two examples, you can see event A has 23 possibilities where event B, let me read again. I read something. Event A has 23 possibilities, while event A not occurring has 40 possibilities. Okay. Find the odd for and against A. So here we are calculating the probability for and against A. And in the second one, we are also calculating the odds for and against B. So you need to know this formula if you want to calculate odds for any event E. Okay, odds for any event E is equal to probability of the event E. You can write this formula. Probability of event E divided by probability of not E, or the complement of E. That is odd for. And the odds against E, against any event E, is equal to probability of not E divided by probability of E. So you can see we just change the numerator and denominator. If it is odds for E, then it's probability of E divided by probability of not E. And then if it is odd against E, we write as probability of not E divided by probability of E. And remember, when you calculate the odds for any event or odds against any event, we need to write the answer as the decimal, not the decimal. We have to write the answer as the ratio. Let's see what is the meaning of that. Let me change the color here. Okay. So here what they said is event A has 23 possibilities. So event A has 23 possibilities of occurring, and event A will not occur is 40 possibilities. That means if you want to know the total possibilities, 40 possibilities of not occurring, 23 possibilities of occurring. So if you add those two, the total possibilities or total outcome will be 63. What we are asked to find is find the odds for and against event A. So the first one is odds for event A, for A. If you want to find the odds for A, it is probability of A divided by probability of not A. And here in this example, probability for A, you can see 23 possibilities of occurring, 23 divided by not A is 40. Not A is 40. So 23 is to 40. So this is the odds for A is 23 is to 40. That's how we write. So once we know the odds for A, odds against the event is just the reverse. You can see these two are just changed. The numerator and denominator are just changed. So you can write, so odds against A will be 40 is to 23. It will just be the reverse order. 40 is to 23. Okay. Then let's look at B. Let's find out what is asked in B. In B, the event B has 8 possibilities of occurring. event B has 8 possibilities of occurring. So event B will occur 8 times, and the total possibility is given 17. This is total. Total possibility is 17. So what is the probability that B will not occur? If you want to find that, B will occur 8 times. Total times are 17. So B will not occur for 17 minus 8 times. How many times is that? Tell me how much is 17 minus 8?
9.
Okay. B will not occur 9 times. That's the meaning of that. So if you want to find odds for, you can see we have to find odds for and odds against B. So odds for B, if you want to find odds for B, it is probability of B divided by probability of not B. Probability that B will occur is 8 times, so 8. Not B, we just found here, that's 9. So your answer is 8:9. 8:9. So what is the odds against then? Tell me.
9. 8.
But, yeah.
That's right. Odds against B will be 9:8. Very good. Okay. So which has more chance? That's what we are looking. Out of 17, there are more chances that it will be against B. That means if you are playing a game or something like that, you have 9 chances of losing and 1 chances of winning. I mean 8 chances of winning. That is the meaning of that. Okay. You have 8 chances of winning and 9 chances of losing. So that is where we use the odds in favor and odds against. So when you're playing some game or you are buying some lottery ticket and you want to see how many times or what is the possibilities that you're gaining or losing. I have seen that this session is about to end. So what we are going to do is we are going to end this session now. Okay, we'll continue with this example. And we are still working on odds in favor and odds against any event E. If you're calculating the odds for event E, that will be probability of E divided by probability of not E. And the odds against any event E will be the reciprocal of that. So it will be probability of not E divided by probability of E. And we always write the answer as the ratio. Here we have 2 examples based on that. Let's read each of these examples and solve it. Let S represent the sample space for the roll of a 6-sided die. That is, sample space contains 1, 2, 3, 4, 5, 6. There are 6 possibilities. And the event C, let's find out what is our event C. Event C is to roll a number greater than 4. So what are the number greater than 4? If X represents the number, what are the numbers greater than 4? Number greater than 4 are 5 and 6, right? When you roll a die, the numbers greater than 4 are 5 and 6. What we are asked to do is we have to find the odds for and against C. So the first one is odds for C. If you want to find odds for C, that is probability of C divided by probability of not C, which is equal to, so in this case, probability of C is to roll number greater than 4, which will be 5 and 6. That is 2 numbers out of 6. 2 numbers out of 6. That means the probability of not C will be 4 numbers out of 6. Then you'll see that 6 and 6, they are same, so they get cancelled. You'll get 2 over 4. 2 over 4, or when you reduce this, it will be 1 over 2. And when you write this as a ratio, this is 1:2. So that is the odds for C. Okay, that is the odds for C. And if you want to write odd against C, it will just be the reverse. So odds against C will be the reciprocal or the reverse order of this ratio, which is 2:1. 2:1. So odds for C, 1:2. Odds against C is 2:1. So there are more chances of not getting the C than getting C, because C contains only 2 elements, 5 and 6 out of these 6. That is the meaning. Now let's look at D. In D, D is to roll an odd number. So when we say odd numbers, tell me what are the odd numbers that you'll get by rolling a 6-sided die? What are the odd numbers there? Please
1,
unmute
3,
yourself.
and 5.
1, 3, and 5. Very good. 1, 3, and 5. So there are 3 possibilities there. So to calculate the odds for and against D, let's first find odds for D. If I find odds for D, that will be probability of D divided by probability of not D, which is equal to, when you say probability of D, you have 3 elements in D out of 6. So it will be 3 over 6. And then not D, not the odd numbers over here. So if you exclude 1, 3, and 5, you'll still have 3 numbers there, which is 3 over 6 again. 3 over 6 in the numerator, 3 over 6 in the denominator. So when you cancel, it will be 1 over 1, which is same as 1:1, equal chance. Okay, there is equal chance of getting odd number and even number. That is the meaning, 1:1. So that is odds for D. So odds again, D will be the reverse order of 1:1. That's also 1:1. So odds against D, that will also be 1:1. So in this example and in the previous example, we look at the ways of calculating odds for E and odds against E. Remember, if you are working in calculating odds for E, it will be probability of E divided by probability of not E. And if it is odds against E, it will be probability of not E divided by probability of E. And we always write the answer as the ratio. That is something you need to remember. When you're calculating the odds, we write the answer as the ratio, not as fraction or decimal. Do you have any question on that before we move forward to the last example? Please unmute yourself.
No.
Okay, we'll go to last example then. So in this last example, we are actually calculating the conditional probability. You can see some information is given in each problem, and then you are asked to calculate probability of C given D, D given C, probability of E given F given E, or A given B. So what you know is these are all the conditional probabilities, as mentioned, conditional probabilities. And you know the formula to calculate the conditional probability. If you remember, conditional probability of A given B, conditional probability of A given B is equal to, we write that as a fraction, and it will be probability of A and B or B and A, which is same thing. So probability of A and B, and we divide that by probability of this second event. When we say A given B, whatever is there after the slash, after slash I have a B, so it will be divided by probability of B. That is the formula for calculating the conditional probability. So in each of these examples here, we are going to use this formula and calculate the probability. So let's begin with the first one. Consider the dependent event C and D, where probability of C and D equal to 0.018, probability of C is 0.3, probability of D is 0.5. We have to find 2 probabilities. The first one is probability of C given D. Let's find that. Probability of C given D is equal to, so first we write the formula. C given D, it will be probability of C and D, probability of C and D divided by the probability of this one, which is probability of D, the second one, probability of D. Then let's write those values. Probability of C and D is given in the problem. What is that equal to? Look at the problem. Probability of C and D is how much? You can unmute yourself.
0, yeah.
Is that right? Okay. Divided by, what is the probability of D? Look at the problem again. Probability of D is equal to?
0.5.
0.5. Very good. Now, please divide this in your calculator and tell me what you will get. Probability of C given D will be equal to how much? 0.018 divided by 0.5. What did you get?
0.036.
0.036. That is the probability of C given D. But in this problem, we are also asked to find the probability of D given C. Let's do that part now. Probability of D given C. Again, we need to use the formula. Probability of these two, which is D and C, or C and D, which is same thing. C and D. And then we have to divide by the probability of this one, which is C. Probability of C. That is equal to, what is probability of C and D? Please read and tell me. Probability of C and D is
0.018.
8 divided by, what is probability of C?
0.3.
0.3. Now please divide that in your calculator. I want all of you to do that.
0.6.
0.06, right? Is it 0.06?
Yeah.
Okay, 0.06. Very good.
Yeah.
Is that right? 0.06?
Mm-hmm.
Okay, great. So do you have any question in the first part? I'm waiting for your answer.
No.
No question on that. Okay. Let's go to B. It is similar. Consider the dependent events E and F. Probability of E and F equal to 0.072. Probability of E is 0.6. Check your note catcher if it is different. It should be 0.6. Probability of F is equal to 0.09. We have to find the probability of F given E. So here we want probability of F given E. Let's write the formula. So it will be probability of F and E, or E and F, which is same thing. And then we have to divide that by probability of E. So divide that by probability of E. Please read, what is the probability of E and F? What is this probability? Probability of E and F is how much?
0.072.
Okay, and then divided by, what is probability of E?
0.6.
0.6. Now we need to divide that. Please divide and find out what you will get. What is that equal to when you divide? 0.072 divided by 0.6 is how much?
0.12.
0.12. Very good. That is the probability. So here in this example, we are learning how to use the conditional formula for conditional probability to calculate these probabilities. In Math 135, you'll see that either there will be a contingency table or a very big word problem from where you have to find all these probabilities and use the formula to find the conditional probability. Here, we are looking at the simplified version of those problems so that you'll be ready to solve those problems in Math 135. Let's look at the last one here. Similar type of problem. Dependence event A and B are given. Probability of A and B is given. Probability of A is given. Probability of B is given. We have to find the probability of A given B. So let's write the formula. Probability of A given B is equal to probability of A and B. Now you know the formula. Divided by probability of B. Now it's your time to read again. What is the probability of A and B given in the problem?
MB.
0.036.
0.036. Very good. And what is the probability of B? Go for it.
0.4.
0.4. Thank you so much. Now simplify that in calculator and give me the answer. What is probability of A given B? 0.036 divided by 0.4 is equal to
0.09.
0.09. Very good. So that is the conditional probability A given B. And this is the last example for today.